Hi everyone. As my friend mentioned, I'm also from eBay. And this talk is going to be about more like high-level stuff. Francisco talked a lot about how do you write the code. I'm going to talk more about what tools you should use in the current JavaScript ecosystem and how not to get lost in the growing ecosystem of JavaScript tools and frameworks. Basically, you have a lot of different tools and a lot of developers get lost. So I created this talk in order to kind of make it better for you to understand this kind of thing. So a few things about me. I'm a software engineer at eBay working in London. I originally come from Poland. You can see here my Twitter ID and as well the link to my blog. And as I mentioned, this talk is going to be about a lot of different tools and a very high-level overview how to basically use them and apply in different contexts. So firstly, basically let me explain you the current content of the web development. Nowadays, we have HTML5, which was certified last year, which was a very important milestone. We have Internet 8 usage very low, which is only 2%, which means that you don't have to worry about the legacy browsers. I mean, less worried than it used to be in the past. We have CSS3, we have ECMAScript 6 getting more and more feature implemented. We have platforms like nodejs, we have HTTP2, which solves a lot of performance problems. And then what's the most important, the user expectations nowadays are really high, so people expect really interactive applications and really fast websites. So suddenly, people come from different contexts and work on different technology. But when I come to the project and see technologies like JSF or Prime Faces or XHTML or Google Web Toolkit, it kind of boggers me a lot because it adds a lot of unnecessary complexity to the underlying web architecture, which is a bit of a problem. So my advice on that is simply try to use web as it is nowadays because it's very powerful. So embrace the technologies like HTML5, CSS, and JavaScript. So how do we build a web application nowadays? There is one model which is very old, which is a traditional page lifecycle. So you simply, from the browser, you hit the page, you fetch the HTML, CSS, and JavaScript. And then when the user does some action, then you have to reload the entire page again, send some post requests, and it's really slow, and basically it's not very interactive experience. So people came with the concept of single-page applications, where you pretty much do the same at the first time, but with the difference that you fetch the code for entire application, and then whenever user does some action, then you just update the very small part, or you just fetch the JSON with the response, and basically you don't reload the entire page, which improves a lot the user experience. So, however, this also has some problems. Twitter experienced that. You can actually check the Twitter blog how they overcome that problem by mixing the single-page applications and going back to the traditional page lifecycle and progressive enhancement. But I don't have a lot of time to actually explain it here. But I created for you a simple checklist. If you are planning to implement single-page applications, you should remember about a few things. First of all, do you need really a good SEO? If you need a good SEO, then a single-page application might be not a good choice for you. If you develop something which is like application behind the login, you most probably don't need a SEO because robots cannot hit something which has to be after authentication. The learning curve, probably if you develop single-page application, you will use some frameworks, either AngularJS or whatever, but they come with a huge learning curve. So be mindful of that as well. The next thing which I mentioned before is do you need a good first page load performance? Because in a single page application, typically you download much more resources than in traditional page lifecycle. So you tend to have much more JavaScript and CSS to download at the first time. So if you need very fast page load time at the first time, then you also need to consider different approaches. And the last thing is that if you develop something, I mean, there was a talk about more like agile. So if you develop apps in different teams and not on the single code base, basically single-page application, it's like difficult at the moment to split the code base, to have multiple teams working in different projects. So it's also kind of easier with the traditional page lifecycle. So let me do some kind of overview of the single-page application. If you finally decide that you actually meet all of the criteria and you can afford of doing single-page application, then you should probably know about the frameworks which are mentioned here, which is like AngularJS, Backbone, and Ember. So I created a simple table taking the statistics from different sources. And here we can pretty much see that AngularJS is the most popular thing on the market. It has the most of the stars on the GitHub. It has the biggest community. It has the widest variety of the plugins which are available. And, well, it's like safe choice for the developers. The other ones used to be very popular. However, the community is much lower. And you can also see here that on the Google Trends that like AngularJS boomed at the same time at one point. So you can see this is a Google trend, and it compares the AngularJS with Backbone and Ember. So you can see pretty much AngularJS is the widely adopted framework at the moment. So if you think about having some longer-term solution where you will be able to easily find developers to work on the project, I mean, AngularJS is a safe choice. However, I mean, you have to be mindful about different things. So what actually if you cannot afford single-page application? If you cannot afford single-page applications and you need to kind of think about building a website in a more traditional way to support properly SEO and other features like which is still relevant. So I usually mix the traditional page lifecycle with progressive enhancement, which are two very powerful techniques, and especially progressive enhancement will people tend to forget nowadays because of this kind of booming of Ajax applications and single-page applications. So basically, traditional page lifecycle comes with that problem that you have to reload the pages. Whenever you do something, you have to slowly reload. So I'm going to address here some of the issues. So one of the issues is that with this kind of first reload, when you start doing traditional page lifecycle and you have like multiple websites as a separate, like completely separate websites, then when going from one to another, then you have this problem. And first of the technique which kind of tends to solve the problem is a hijacks. It's an Ajax technique which basically it's about hijacking the response. When you load the page, do some action. Instead of doing typical HTTP post, you will have some code which will hijack this response. And instead of sending the typical HTTP post, then it will send the Ajax request in the background, which drastically improves the user experience because you don't reload the entire page, you will just reload the part of the page. So this is pretty much how it works. So you do some action, then you have the Ajax request, and then there is no page reload. But when you start using that, you will quickly find the problems that you don't have the URLs. I mean, because as more you put Ajax functionality in the page, then you lost this powerful, natural way of how the web is built. So URLs are still very important because you want to be integrated with the browsers. Whenever you go back and forward, you would like to actually use that thing to navigate over the page. So you need to provide some mechanism that will keep the history and will manage the state associated with the URLs. So there was a way, for a long time, they solved it with the hashbanks URLs, but that was really not really nice syntax and not really nice way of doing stuff. So HTML5, in HTML5 standard, they developed basically the technique for that. And the other thing is that if you have the URLs, you can properly bookmark the page. So imagine a lot of people do bookmarking. If you want to send the link to something, you most likely would like to send the link to the same state of the application than you are in, that your friend can also see the same. So that's why it's also important. So as I mentioned, there is a problem solver for that, and it's HTML5 history API, which is now basically supported in all the browsers, Internet Explorer 9 and above. And coming with that, there is a technique called PJAX, So PJAX is about, I would say, fixing the hijacks problem. So basically, it's kind of similar. So you do some Ajax action, and then in the background, you also update the URL with the browser using this history push state API. So it's pretty much like that. So again, no page reload, however, you get the proper URLs. So whenever you start doing more and more client-side logic, then you quickly find the problem that a lot of the code gets duplicated, both on the client side, which is the browser, and both on the backend side, which is the server. So things like localization, rendering templates, date currency formatting, form validation, routing logic. So it's the thing that we had a problem in one of the projects that we worked on. And because we were actually, in this project, we were unable to solve the problem because we were like on Java stack, and then on the client side, we have JavaScript. Then we figure out how to switch actually to different technology, which will allow us to actually mitigate this problem of code duplication. So one of the examples of this would be, the specific example would be like form validation. You have very simple, interactive form, and you would like to provide the feedback to the user as soon as possible. So you most likely implement the client-side validation. And then, because you don't trust Ajax, of course, you cannot really ensure that the data comes, because people can do some XSS injection and so on. So you need to also make sure on the backend that it's also validated. So that's why it's kind of problematic. So there was basically, then it comes the concept with the isomorphic JavaScript, which was mentioned, for example, by Airbnb. So they wrote this article like a few years ago, and basically they introduced this concept of running the same code on both server and the client side. And basically, this can be only possible if you use actually the same the technology, the platform, which supports the same language on both sides. And as you can see here, it's about having the common part, which is the areas that I highlighted before. And this part is shared across client and the server. So this is pretty much how we kind of doing this at eBay for the new applications. At eBay, we have to support different platforms. We have to support web applications, and we have to support native applications. In the web applications, we support multi-screen devices, so the same experience has to work either on iPad or either on all different sorts of devices nowadays. So we decided that because we have all the variety of devices that we have to, it's going to be much easier if we develop the common services layer. And this layer will be consumed by either native applications directly, or either through this kind of thin UI backend layer, which would be the nodejs in our case. And this backend layer would be kind of responsible for the areas that I highlighted, like form validation, like all different things that has to be done on the backend. So, and then when we talk about all of these different technologies nowadays, I mean, all of these different advanced way of writing the code, we realize soon that, okay, we cannot really do that without the tools. So we need to have tools nowadays for front-end development because they allow us to be faster, more productive. They allow us to write CSS much faster because we can use the less CSS preprocessors like less or SAS. We can reduce a lot of boilerplate code which we have to run, we have to build in the web development. A lot of manual work you have to do, like you have to also, like, for instance, no one likes to generate the sprites because he would have to go to Photoshop every time he wants to add the new thing. So there are tools which actually automate the steps. And the last thing, also very important, the optimization part. You need to make sure that your page is really fast. So you have tools which helps you to optimize the compiling CSS, minifying, basically gzipping, and all of that. But well, as I said, people come from different backgrounds, And now suddenly they all have to use Node.js because it's the best ecosystem for the front-end tooling. And that's true. I mean, you cannot compare Node.js ecosystem for the front-end tooling with any other kind of technology nowadays. So people tend to use this nowadays with Java, with Ruby, with PHP, with everything. So let's talk about some more practical stuff. So when you already decide to use this Node.js tooling, there is actually a guy which is called Yeoman, and he will help you with actually starting this kind of tools exploration. So Yeoman is a tool which helps you to generate the Bootstrap project, like a skeleton of the project. So pretty much how it works, you go to the website, which is yeoman.io, and then search for the technology you would like to use. Let's say I would like to use React. So you type React, you fetch the generator, you install it on your system, and then you execute the command like with the name of the generator, like let's say yo React Webpack, and this will ask you a few questions about what kind of configuration you would like to have in your project. So it will ask you whether you would like to have like either less or SAS preprocessors, whether you would like to include Karma for testing, whether you would like to have different set of tools in your project. So at the end, it will create some sort of configuration files in your project. One of them will be Grunt file, and Grunt file is something like some sort of build script. I mean, I would compare it like in Java you have Ant, in Node.js pretty much Grunt file would be the most popular. And it will define for you the tasks that you use in your developer workflow. So for example, like the task for testing, the task for building your CSS, the task for building your JavaScript, and the task for running the local server. We have, of course, the other tools on the market. We have one of the most popular is Gulp, which has the most of the stars on the GitHub. The other one is Grunt. And I would say that those two, they have the biggest adoption, so they are very safe to use if you consider like running the project for more than 1 year or having in the mind to actually support this project for a long time. It's the safest way for you to decide on the tool. And the other ones, they are less popular, so however, they are very interesting, so I also encourage you to explore different, but for the longer living project, I would actually recommend you the first two. So let's talk about the differences. Why Grunt or either why Gulp? So Grunt is, as ThoughtWorks says, it's a basically global company which does consulting, and they consider the Grunt file nowadays as a JavaScript de facto build tool. Because, as I said, it has the highest adoption, it supports the wider set of build-related activities. And the second one, Gulp. Gulp is slightly different. It has different way of kind of creating your configuration. Rather than creating this in the declarative way, you will be using the streaming API. Anyone familiar with kind of concept of streams? Yeah. So if basically you are familiar with concept of streams, then you pretty much create a stream from the source files, apply different transformations. Like here you have the example with coffee, compiling the coffee script, and then uglifying that, which means minifying and obfuscating the code. And then at the end is kind of piped into the destination folder. So in the more advanced example, when you have multi-module project, you can apply different pipes for different things, and they all will be processed in parallel, which is quite fast. I mean, this kind of part is much better than in Grunt. The most important difference, if you consider that you would like to have your build as fast as possible, Gulp doesn't have the problem of intermediary files. Grunt, the way how Grunt works is that when it does the task, it will basically do the task, copy the file to some temporary folder, and the next task will pick the stuff from that folder and do stuff again. So we'll have a lot of writes to disk, which is quite slow. So Gulp does all the things in the memory. So once you start the stream, everything is processed in the memory, and then until it's written into the destination folder. So this is the biggest advantage, I would say, of Gulp. And the next thing, which is quite cool, with some plugins, you can configure Gulp in that way that it will remember the parts of the build. I mean, if you have the multi-module project, you can pretty much, and you build one module and you don't want the others to be built because they are slow, then it will always just build stuff incrementally, just the needed part which was changed. And it won't rebuild the another things. But yeah, this is something you have to figure out how to do, but at the end it's possible with Gulp. So as I said, it's the biggest quick recap on that. Gulp versus Grunt. No intermediary files in Gulp. Faster builds, and also if you prefer writing code as opposed to writing configuration in the huge JSON files, then the Gulp might be better for you. And also the streaming API. So I have 4 minutes left. So I'm going to briefly talk about how do we structuring the code. We have, because it's kind of connected to the how do we build our project. So we have few patterns. One sock drawer pattern, used especially with the, if you start AngularJS project, for instance, you have folder structure like you have controllers, services, models. So if you create a new controller, you just throw it into the controllers folder. And that's how you structure the code without even thinking about different domains. It's kind of easy to start, but it doesn't really scale because you have a lot of different controllers and they are not really related. So that's why you have the other pattern, which is called modular. And modular, pretty much you slice your code across the different domains. So you put each controller, services, and models into one directory. And when someone comes into the project, and he needs to change stuff in one particular domain, then it's very easy to pick the dependencies for him because he just see everything in one folder. And one of the last and my favorite is modular, but with assets. So if you create the front-end modules, it's really nice if you have this kind of structure that you put everything together in the module, including CSS, JavaScript, and the HTML markup. It's important because everything is related together, and when you achieve the structure, then it's very easy for you to reuse the code. I will talk about this in the context of the tools in a while. And now you have something like, when going to the kind of less high level, I'm going to talk about different ways of defining your modules. One of the old way is that you create the namespace. Probably most of you are familiar with that pattern. And then when you want to reuse some dependency from another file, you would reference the global context with the namespace and access the dependency from there. And in Hello World, you have the access to all dependencies. But this comes with the boilerplate you have to create. Every time you create this kind of thing, you need to make sure that all dependencies are loaded on the page. It's a bit of manual work you have to do. This is the example with Grunt file, how we can do that. So developers figure out the better way that this sort of work can be automated. So they created tools like Require.js, which was following the AMD structure. You can see here the same code, which is doing the same, but without kind of relying on this kind of global namespace. So I don't like it. People didn't like it, so the structure is not really that nice. So they created something like CommonJS, which is also the better syntax. But at the same time, what's the most powerful is that it's the same syntax that you can use on the server and on the client. And at the end, it's like basically the first step to start doing isomorphic JavaScript. So because this is not a standard thing, in JavaScript, it will not work in the browser out of the box. So you need special tools which will actually help you with using that stuff. So there are two different tools. One of them is Browserify, another is Webpack. So both of them support the CommonJS syntax, so you can have the same piece of code on the server and on the client. And they work with dependency managers, which I'm going to talk about in the next slide. So dependency manager, from the other side, they allow you to basically put your separate your front-end module and publish them in the external repository, like something like Maven or something like that. And then you can reuse it in different projects. And then when you start using them, like let's say NPM is the one popular, and when you start using them with the structure that I presented you, like modular with assets, it works perfectly because you have here the calendar widget. So you simply publish this calendar widget into the remote repository, and the guys from the other projects can simply do npm install calendar widget, and you have calendar widget in your project, which is awesome. I mean, that's the most powerful thing in that kind of tooling. So I'm going to quickly skip all of these slides because it's the end of the time. So as I said, at the end, just to summarize, I created for you this kind of, the kind of map of how to actually proceed with different tools. I mean, when you do single-page application, it's kind of easy. Okay, most of you probably will choose AngularJS. But if you decide to go a slightly different approach, like starting with the traditional page lifecycle and implement stuff more incremental way, then you would basically start from like easy learning curve technologies, which is HTML5, CSS, JavaScript, and then something for testing. And then you progress through more medium kind of advanced tools. And then you simply pick up the tool whenever you need it. Not, okay, because someone said, okay, we should use Angular for everything. You simply choose the tools to solve some kind of problem. So, and you don't always choose the most advanced tools at the beginning. It's basically when your project grows, then you can decide to choose these kind of medium tools. And if you work really like in the kind of large-scale application environment like eBay, then we tend to choose more advanced tools which solves like the most advanced problems. And yeah, that's pretty much it. So thanks for that. If you guys have any questions, after the talk, I'm available, and you can just talk and just ask anything. Thank you.